Assalamualaikum. So today we're going to discuss chapter 3, the performance evaluation on page 73, 74 and 75. So I'll discuss roughly how to answer the questions and you can try on your own. Okay, so question number 1 is, okay, before you answer any question, you have to know the question is about which subtopic. So we learned for chapter 2 we have 8 subtopics. So 2.1 until 2.8. So which part of the question is that? Okay, so for question number 1, so when you read the question, you should know question number 1 and question number 2. This is about the linear motion. Okay, so involving linear motion means we have 4 equations to consider. Okay, so we go one by one. Question number 1, a car moved from rest with an acceleration of 2 meters per second square. Calculate the velocity, distance travel, distance in the first second. Okay, first thing you have to highlight, a car moved from rest. Rest means stationary, tak bergerak, so your U equal to 0. Okay, this thing you have to list down to highlight. And then acceleration, okay, so this is the A. Question is, calculate the velocity after 5 seconds. So this is the T. Calculate the velocity. So the question is asking about the V. So when you list down, you have the A, you have the U, you have the T. So you're going to calculate the V. So you can decide which equation you want to use. So just list down the 4 equations. V equal to UT. Then we have half plus AT square. Then what else? We have V square, U square plus 2as, and another one s equal to U plus V. Okay, T. Okay, so usually ini kita jarang guna lah, kita akan gunakan 3 ni lah. Okay, no problem with that. Okay, so when you list down, you can see you have the U, you have the A, you have the T, so you're going to calculate the V. So you can use this equation for question A. So for question B, distance travel in 5 seconds. So again, you have the U, you have the A, you have the T. So you have the U, you have the A, you have the T. So you're going to calculate the S. Okay, you can use this equation for question B. For question C, you have to really understand the question. Distance travel in the 5th second. Okay, pada masa kelima. So benda ni dia gerak from 0. Okay, then they accelerate. So 1 second, 2 second, 3 second, 4 second, 5 second. So dia kata ketika masa kelima, bukan setelah 5 saat. Setelah masa kelima means dia gerak dari 4 nak ke 5. Kat sini. Distance kat sini je kita nak cari. So what you supposed to do, you have to calculate S ketika 5 saat tolak distance ketika 4 saat. S 5 saat kita dah kira kat sini. So tolak 4 saat kat sini. So you ganti balik 4 second over here. So S5 minus S4, so you get distance kat sini je. Okay, so that is for question C. Okay, please try that. Okay, now question number 2. Question number 2 is still about linear motion. So again, when you read the question, list down. Encik Nizam drive a car of 108 km per hour. Suddenly he sees a car in front moving very slowly. Therefore, Encik Nizam slows down his car to 72. The displacement is 125 meter. If the acceleration of the car is uniform, means sama je kat mana-mana. Calculate the acceleration. Time taken to reduce from 108 to 72. Okay, first thing you have to remember again and again, this is not SI unit. So you have to convert 108 km per hour to SI unit, which is meter per second negative 1. So kilometer to meter. So we know 1 kilometer 1000 meter. So hour to minute and to second. So 1 hour 60 minutes times 60. Then you get a second. Okay, convert this part. Convert this part. Okay, this one is in meter, this one in kilometer. So tak boleh buat lah. Okay, so when you list down, so what is this? This is your U. This is your V. Okay, then the displacement. Okay, this is the S. So calculate the acceleration. One more time. Choose these 3 equation. Okay, kenapa kita tak pakai keempat? Keempat sebab dia tak ada A lah. So kita tak pakai lah, tak ada A uniform. So you use this one. So b square u square plus 2as. Okay, calculate the a. First cari a dulu, lepas tu baru ganti dalam equation. Then time taken pun sama juga. You're going to use the same equation. You get the a, so you might use b equal to u plus at, so you get the t. Okay, so dalam kes ni cari a dia dulu Cari a dulu, then baru u guna. Memang kena cari a pun. V, u, s, carilah a. Okay, so this two is about linear motion. Okay, question number 3. Read the question properly. 9 rows a boat forward. She used oar to push the water backward. Ni menatang apa ni? Ni pendayung lah. Why is the boat able to move forward? Okay, dia push the water backward. Tapi the boat move forward. So, ini tajuk apa? Okay, so you just answer in 1 or 2 sentence. But in your answer, mesti ada apa prinsip yang awak pakai. Initial ke? Momentum ke? Okay, I give you the idea. The idea is Newton's third law. Newton's third law. What is Newton's third law? Every action has reaction, equal magnitude and opposite direction. So you push backward, then there is a force to push you forward. Equal magnitude, opposite direction. Okay, you can also use the concept of momentum as well. Okay, but this is the keyword. This sentence must be in your explanation. Okay, now question number 4. A car with mass 1,200 kilogram at rest is moved by a force of 150 Newton. Determine the acceleration of the car and the time taken for the car, time taken and acceleration. So 2 questions. For the car to reach a velocity of 1.5. Okay, again, so this part, this is your mass, M. This is the force, F. This is the V. Then initially from rest, U equal to 0. So you're going to determine the T and the A. So, this is about, okay, chapter apa ni? Oh, sorry, subtopic apa? Okay, I give you the idea. This is about force. This is about Newton's second law. So, Newton's second law states that force is the rate of change of momentum. So, we can apply F equal to ma. Okay, so you can get the A. This one equal to mv minus mu over t. Okay, because A is v minus u over t. So once you get the A, so you have the v, you have the u, then you can get t. So check again, is everything in SI unit? Yes, everything in SI unit. So you get the answer directly. Okay, so this is for question number 4. Question number 5. Okay, question number 5. I skip this part, 2.8, because it's very easy, 1.5 page only. So question number 5 is about weight. Weight is the measure of the force of gravitational force. Okay, so this one you please refer to page, your textbook, page 71. Okay, the answer is there. Very simple. Okay, now question number 6. Cepat nah. Okay, question number 6. A bullet of mass 10 gram is fired from a gun of mass 2 kilograms. So we have two objects, a bullet and a gun. If the recoil velocity of the gun after firing it, the shot is 0.5, calculate the velocity of the bullet. Okay, recoil velocity means you tembak dia ke belakang kan. Tengok dalam cerita-cerita bila dia tembak dia akan dari tujah ke belakang. So that is recoil. Okay, so tajuk apa? Bullet, mass, velocity. We have mass, we have velocity. So this is supposed to be momentum. So you know the subtopic dulu, barulah ada idea nak jawab. So what is momentum? P equal to mv. So we have before bullet, sebelum dia tembak dan selepas dia tembak. So means you're going to apply conservation of momentum. Total momentum before equal to total momentum after. So what do we have? We have mass of the bullet, initial velocity of the bullet plus mass of the gun, initial velocity of the gun. This is before. Sebelum dia tembak, peluru tu duduk diam je dalam pistol tu. Dah start tembak, So pistol tu akan ke belakang, peluru tu akan ke depan. So we have mass of the bullet, velocity of the bullet, plus mass of the gun, tapi dia kata recoil, gun to recoil. So velocity of the gun negatif lah. Okay, sebelum tu tembak lagi, pegang je, tak tembak lagi, tak bergerak. So U0, so this part 0 lah. Soalan nak apa? Calculate velocity of the bullet. So soalan nak VB. Okay, so ganti nilai, so you get the VB. Okay, so MBVB plus MG negative VG. Okay, so cari VB. Okay, again, consider this part. The mass is 10 gram, but the gun is kilogram. So mass of the gun tak ada masalah. Mass of the bullet kena convert to kilogram. Okay, all this benda-benda kecil, kalau lupa consider, habis. So that's for question 1 to 6. Now we go to the next part. Question number 7 until question number 9. Okay, question number 7. Question number 7, you have to sketch a graph. Okay, this is terrible. Photograph 1 shows a car moving along a road. Initially, the car moved at a uniform velocity, laju seragam, for 15 seconds. Then accelerates 1.5 for 5 seconds. Subsequently, the car starts to decelerate 15 meters per second in 5 seconds. The car continues to move at this speed for another 10 seconds and finally decelerates again and stop at 50 seconds. Based on the information, sketch the velocity graph of the motion, shows the values of velocity and time in your sketch. Okay, this question, okay, listen properly. This question contributes a lot of marks. Okay, soalan graf ni kalau keluar banyak markah. Sebab apa? You buat part C dah dapat markah, you buat nilai dapat markah. So you garis 2-3 garis pun dapat markah. Okay, so now this one. Okay, we have to sketch a graph. Oh, sorry. Okay, we have graph of V against T. Okay, so V against T. Okay, let's start with the T. Okay, so the car moved at a uniform velocity for 15 seconds. So let's say over here 15 seconds. Okay, so nanti awak buat ikut scale je cantik lah. 15 seconds, then they move for another 5 seconds. So means 20 lah. 5, 15, then another 5 seconds. Decelerate in 5 seconds lagi. So 25 seconds. Then what happened? The car continue to move for another 35 seconds, 10 seconds, so 35 lah kat sini kan. So dah 25, so for 10 seconds lagi. Then finally they stop dekat 50 second. Okay, so this is the scale. Okay, so where should we start? We start with 15. So, sorry, initially move with 18. So we start with 18. So over here 18. Then dia kata dia turun sampai 15. Dia turun sampai 10. So ikut scale ni dulu. Mungkin kita kena tambah lagi sikit. Okay, now we want to start the graph. Okay, so we can see here the car move at uniform velocity. Ini graph V. Okay, so boleh tulis unit dekat sini ya, tulis unit dekat sini. So graph V 18 selama 15 saat. So 15 saat uniform. Sepanjang 15 saat tu 18 je. Okay, so sampai 15 ni dia sama. Okay, then accelerates. So bila dia accelerates 1.5, so bila dia accelerate selama 5 saat, memecut, dia tambah laju dia lah. Dia tambah laju dia Selama 5 saat sampai 20 sini. Okey, berapa nilai kat sini? Dia pecut sampai berapa? Yang ni kita boleh kira. Macam mana kita nak kira? Kita pakai equation linear motion tu. So, in 5 second, initially dia start 18, acceleration dia 1.5 in 5 seconds. So, you should get 25.5. Dia pecut kat sini. Okay, after that, subsequently, decelerate to 15. So, 15 tadi kita dah set kat mana? So, kat sini 15, let's say. So, dia decelerate. Okay, buat je nanti lah, straight. Okay, so decelerate, okay, sampai 15 kat sini. 15, lepas tu continue move at this speed. This speed tu apa? 15 lah, for another 10 seconds. So daripada 25 sampai 35, another 10 second. Then decelerate again until it stops. So until it stops sampai kosong. Lepas tu sampai sini. Decelerate. Okay, buat cantik lah. Decelerate. Okay, so that's your graph. Okay, so for graph again, marks are given banyak lah kat sini. Setiap ni buat part C dapat markah, buat part C dapat markah, tulis V, tulis T, buat garis-garis yang elok lah. Okay, so this question number 7. Okay, tolong study lebih sikit, tolong faham the graph. Okay, so we move to the next question, another graph question, but this is about free fall. Question number 8. Question number 8. A rubber ball is released from height h. Release means u equal to 0 lah, lepas je. The ball drops vertically downwards and upon hitting the floor, bila dia kena lantai, bounces back at a height of h. Tapi tak setinggi h yang awal kita lepas tadi. If the velocity downward motion is negative, so ke bawah negatif, sketch the velocity time graph for motion of the rubber ball. Okay, now cuba bayang je lah. Okay, so for question number 8. This is question number 7. So ada sebiji bola. Dia lepas dia. So dia jatuh. So V ke bawah is negative. So ini H. Sampai kat lantai, what happen? Dia rebound. Sampai sini H. So V ke atas, positive. So from here, sketch a graph. So graph apa? Graph V against T. Okay, dia ke bawah, dia negatif. So bahagian ni lah. Ni V positif. Ni V negatif. Sini kosong. So you start release. Release, dia kosong. Ada pecutan tak? Pecutan dia free fall. Pecutan dia apa? A equal to negative G. So pecutan dia sama je kat mana-mana 9.81 ms negative 2. Dia naik balik pun itulah G dia. Dia turun pun itulah G dia. Okay, so means ketika dia turun, H besar dia. Macam ni. Okay, H ni. Sampai kat sini dia lantun balik. So kita sambung. Dia lantun balik. Sampai kat sini dia lantun balik. Tapi dia semakin laju ke semakin kurang? Semakin kurang lah. Ini H. Okay, ini H besar. Ini H kecil. Kenapa ini macam ni? Sebab bila dia naik sampai satu peringkat, dia akan sampai sini. Dia stop lah. Dia akan turun balik. Betul lah. Dia naik. Tapi kenapa ke atas? Sebab ke atas positif. Dan kenapa yang ni ke bawah? Sebab semakin lama dia slow sikit lah. Awak naik atas. Slow. Yang ni dia laju. Sebab dia turun. Okay, so this is the graph. Macam pelik kan, graf dia ni untuk H besar, turun, dan naik